Hey everybody, Dave and I ran into a weird problem today with the Woodmizer. Earlier today I noticed that the saw, there's a rooster tail of sawdust that comes out behind your blade, and a good sawyer will always keep his eye on that, because when the blade is deflecting, that rooster tail will come up. If the blade's deflecting down, the rooster tail will shoot up, and when the blade deflects upwards in the cut, the rooster tail will shoot down. So you always try to keep an eye on that. And I noticed something that I never noticed before, and that the rooster tail was pumping today. It was just spurting, but very quickly, maybe 25 times a second. And I couldn't figure out what it was because I'd never seen it happen before. And so I kind of kept an eye on it, and the saw wasn't responding the way I wanted it to. It wasn't running at full speed. It was kind of laboring through the cut, even with brand new resharp blades. So I couldn't figure it out. I kind of, on a previous video, I was making gestures like this to Dave, like I can't figure out what's going on. And then we replaced one of the blades. As soon as we went to fire it up, the blade jumped off the wheels. So that's happened to us before. If a band gets twisted before it gets resharpened and I haven't labeled it correctly. So we said, all right, we'll put on another resharp. We put the second resharp on, and it immediately jumped off the blades again. So I knew something was wrong. So my initial thought was that this idler wheel over here, Dave's gonna pan out. I thought that this idler wheel had been canted in because I had put a lot of tension on the blade. I put about an extra 5,000 pounds because at first I thought it was maybe we just needed more tension on the blade. So normally we keep about 26,000 pounds on the blade. I put about 31 on the blade. And I thought that the tension had actually pulled the outer rim of the wheel in and it was dumping the blade forward, right? But that wasn't it. So we set the tension back to 25,000 on it. It still dumped the blade. So I told Dave, let's do something a little bit dangerous, but I guess I'm comfortable with it because I've worked on machinery and made machinery the last 20 years. I said, let's just run the saw. We'll ease it forward with the throttle with both cases open so I can watch and see which wheel is dumping the blade. So immediately the back blade started to ease, the drive wheel started to ease the blade off forward. So I knew this was the problem wheel. So we detensioned the saw, we got the blade back on the back wheel, the drive pulley, shiv, whatever you want to call it. I told Dave, let's tension the saw blade back up to 25, 27, what we normally run it at, and to ease it forward very slowly. So as I'm watching it, I noticed that the blade back here, as it's running, looks lumpy. And so I jump across to the forward side of the saw, and I'm looking at the idler wheel, and what's happening is the idler wheel is running dead smooth. It's running dead concentric as Dave's slowly easing the saw blade around by feathering the throttle. So I go back to this wheel and I verify that it's basically pumping. It looks like it's pumping the blade. So I realized that's probably why the rooster tail was pumping too. Something cyclically was wrong over here. So what happened was I told Dave, I said, let's take off the blade, let's take off the V-belt. I think stuff is packed in the V-groove and it's causing the saw, not only when the lumps come around down, it's causing the blade to flex down. When the lumps come around the backside of the saw, it's stretching the band constantly with every revolution. So it's causing the blade to deflect, and then when it comes around back here, it's pumping the blade and causing the blade to basically over tighten and then slack, over tighten and slack. So Dave and I took the band off, and lo and behold, I took a picture or two, so we might put that in the video. But these are all hardened pieces of rubber that were basically impacted onto the face of this entire groove. And we went around with chisels, a screw, and a scrunch, basically. And basically, you can see how big some of these chunks are. They're huge. And they're not thin either. They're probably about 1/16 of an inch thick. And they coated the entire inside of that V-groove. So we pulled it out, we cleaned it out, and we are about to blow out the case to make sure none of those pieces get back into the V-groove. We're gonna blow out the brake, and then we're gonna run it, and I'll let you know in 10 seconds in the next cut of the video if that was the actual problem. We'll be right back. That's exactly what the problem ended up being. The blade, when you're looking at it and it's at full throttle, but you're not in the log right before you enter the log, you can always tell that there's something wrong with the blade, how it's not tracking or something like that, if the blade is pumping or wandering on the wheels. And it's running dead flat now. We just took our first cut back in the log, and now everything's cutting dead flat and it's not jumping off the wheels. So just for your information, we probably, I don't know, I'm trying to guess now, we probably have maybe 130,000 board feet on this saw, maybe a little bit more, maybe 150,000 board feet over the last 2 years. So the blade basically got impacted with all of that garbage, carbon, sawdust, and rubber over 150,000 board feet. So if you're in that neighborhood, if you're up over 70, 80, 90,000 board feet, check the drive wheel to make sure you don't have that impacted rubber. And that's just another variable to keep in mind when you're running a mill. Just keep that shiv valley that runs the actual band clean of rubber. All right, guys, we'll catch you on the next one. Thanks. So that's exactly what the edit